Hello, welcome to this module. It's an exercise module and I will go in depth to steps and using the lambda calculus, and it's about how to get friends with books. So without reading them. So how to be able to talk about books without reading them. So this is what I think is what the social media are doing. So and we have to skip this idea that you need to understand a book before being able to talk about it. This idea is not adequate anymore. So in our vocabulary, we have to think of a book as a stupid sequence of characters. So this is what we call big data. And this is what we have at the memory of the last day. So it's not talking anymore, it's not present, it's not there, but these traces of the last day. And they're not vivid anymore, just no understanding, just a sequence of characters. So that's big data. Forget about reading it, forget about understanding it. They make no sense because it's just a sequence of characters. Stupid. On the other hand, this is orthographia, the memory of the last day. On the other hand, we have the generic algorithms which can do anything, ichnographia, and these are the dreams of the last night. And they can ask anything and they do whatever you like. So these two are two legs of this triangle, the dreams of the last night, so AI, and the memory of the last day, so the sequence of characters, the orthographia or big data. And you now, or we now, learn to bring these two these two elements into proportion. The last day and the last night into a proportion to constitute the new day. So this is exactly what we're doing if we ask social media or in the internet with the Google metrics. If we ask any question, the whole planet is turned towards our question and we get some reflections of that. And all this is working because Google doesn't understand, doesn't pretend or doesn't want to understand anything about what is going on. And so it's just the connectivity of dead things. And it needs a question to make, to create some meaning. So this is what we want to do with the book. Therefore, we think it's not about understanding a book, getting friends with it. And we want to learn some techniques of writing in code to have this new access to building to books as Google has to all media on this planet. So and start to work with it. So and it's quite just the same as we had with a perspective drawing in Renaissance. There, a thing could be turned to any perspective with a certain technique of the perspective drawing. Now with coding, it's a technique to turn whatever media we have to a certain perspective, which is our question. So therefore, it's about getting friend with the book, not to understand the content, or to read the content of a book in certain schemes. So these are exercises how to do that. Let's go. And I have some chapters, 8 chapters. The first is import a book to this environment. This is unfortunately in the cloud. It is a little tricky if you have a license for Mathematica. it's quite simple. You simply say data is import, and then you get, let's go for Xenoteca, just there to get an idea of how it works. Go, for example, for Kohlhaas junk space. Here we have these links. Copy this link. Say I want to have this link, X. I want to have that as text. You see there's a lot of different formats in Mathematica. So have this. Simply say we want to have to import that, and here it's there. There might be a question about the password and access. It's already established in here. So that's it normally. The problem is this is not working in the cloud because you can't have this authorization process to a password protected site without paying in the cloud. And therefore you have to hustle around a little. So let's go back here, go here, copy, and then you need a text editor. You can't use Word or Pages because it's always about formatting and so on. You need a plain text editor, as simple as possible. And I just take here text edit. It comes with all OS X. Make a new file. Get rid of any formatting to make plain text and paste. So you need to change two things. All the quotation marks are showing, if you have a string, you know quotation mark starts, then there's a sequence of characters, and quotation marks ends the character, the string. If there is a character in the string, then you run in problems, of course. Therefore, we replace all the strings, there's none in this text, replace them and say with a single and say done. So the same is with the backslashes. Replace. There's a backslash which always means there are special characters following. And I would suggest just to make it simple, just delete all of them. In this case there is none. For example, backslash n means a new line. So then this means it's with backslash, then there is a command, and this command says go for new line, but don't print the n, and then continue. In this case, simply delete it, I think, is enough for our exercise. There, of course, there will be more detailed correction necessary if you want to go professional. So, place, no, find, place, all, done. So, copy this and go to our cloud. Now we go and create a file, new file. We have it here, a new file, and then we say data equals, we start the string, and then we paste our text. This takes time in the cloud, and I think there's a lot of communication with your client here, with a web browser, and the server in the Wolfgang cloud. Therefore it takes long, and therefore it's near to impossible to work especially with images, with movies, or with audio data in the cloud. So you need these things. Simply have to wait. Then it's coming. Here we are. So we start this text. We deleted all quotation marks. So therefore we can go to the end. And then here we have to be patient. This is internet is not made for this kind of stuff. So now put this semicolon behind it so that you can evaluate data. So assign the book to the symbol data. This is what we did. So now you can delete it and ask what is the data. So head, what is assigned to the symbol data, and then system says it's a string, and then you, for example, can ask string length of data, and then system says 100,000 characters. So this is our book collage. So to put it and save it, we do the same thing. We say export. And here we can go for documentation, or here you can look up how it works. You have the file name and then the expression, file name, expression, format. We take this one. So we say the file name. We simply say, if we want to have it in our cloud, we say cloud object of, and then we say my first book. Expression is data. We can go for compress, and it's not this when it's compressed, and the format should be simple text, plain text format. We don't have it, but it's not properly. So we put it here. So we have to make a cloud object is here, and then the export is here. So go, and here we have the cloud object of the first book. So you can publish this, but then you need to go over here with publish. So, but we do that later if you're interested. Now the other way around is that we can go. No, it's safe. You see, it should be here. My first book. So to import that, we have to make just the other way around. For example, now you can say quit the kernel. We say data is, and that's what we did directly here with the Mathematica. This was here. Now we did this again, but with our local file, which is fortunately is working. So we say uncompress of then import of cloud object my first book, and the format is text. So if we have that, it's there. We deleted all thing. So again, let me show how this works. If we have that, then normally in the cloud it's not super robust. It's blue. This means it's a symbol. There's no assignment to the data. Now we can ask what it is. Then he said there is no string length on the symbol, so that's okay. Export, now we can say import of that, and then we have the data, And now we can ask for a string length of data, and then we are there again. So this is how it works. So we can save this document now, getting friend with a book. That should be there as well. Getting friend with a book. Good. That's it. How to import the book. Next chapter. The simplest way to deal with it is find a sequence of characters in book. For example, we want to look what is Kolas talking about architecture. So we want to find sequences of A, R, CH, and so on in the book, and look what is the environment of these characters. So therefore, take the code here. Let's look what's going on. So import. Yeah. Nah. So now how was it called? Find a sequence of characters. So we do it again now with this character return to be safe, and you see here this exception character, and then you say the next one is not used as the proper character. So this exception, and by that this one is not the end of the string. So this is what we did in our text editor. We replaced the character return with blank, and we replaced the quotation mark with a single mark. So we do this, data 1, and assign it to data 1. String replace, if you want to check it, you can look it up here as in the documentation, but now here we say, for example, hello, and just try the same thing. So we, for example, we can have H, then rule, for example, say H, and then there's hello with a capital letter. Or we can go here for L, and we can say L should be double capital L, and then we get this hello. Good. This is the first step. Second step, we don't want to be, this is here to lowercase. Second step to lowercase, this is what it is, what it says. If you, for example, so you can go here for hello, and if you say to lowercase of this, then you get lowercase. So it doesn't matter whether you have it at the beginning of a sentence or if you have, so we simply want to abstract from that to find our sequence in string. So therefore we have to, this is still blue, we have to evaluate that. We can check data 2 now, that should be around the same. Yeah, it's the same, but different characters. Good. Now, this is what is interesting. We'll see what's work. For example, here we ask, let's test how it works, whether it works. Yeah, here. This is how it works. We ask for the string blank, infinity blank. So, and then we get the environment of the character, and we get it in an editable way, like this. Now, I show you how to learn to read the code. You see riffle, you can double click here, and then you see where it starts and where it ends. String join, it joins strings obviously. You can look all these things, you can look them up, what it is about. String take, string position. So let's start. So this is the most inner part, and this is directly with our data. So this is, I think, it looks like, so double click, desktop, it's simpler. Take this and just look what it does. So it gives you the characters where the position within the data 2. Data 2 has 100,000 characters here, and it gives you the positions, 2 positions of infinite. So that's fine. String take, for example. So that's okay, yeah? So now say string take and ask what is string take. You can go here. Come on. So it gives a string containing the first n characters in a string if we have 1. But yeah, okay, the first one, so try it. So if we say hello of a string, so it needs to be a string, hello, and give the first n characters, so we say 3, so this gives hell. Okay. So then give the nth character, and this is what we want. We give character m through n in string, so this is 3 to 4. Then we go for the 2 else, 3 to 4. So if we have that, then we can, for example, say data 2, and then we can go here and delete this, and this should work. It's infinite, of course. So, and now we can say, this is what we are doing here, we say plus which is here, which is minus 20 here, plus 20 here. So we can go here, and then we see what's happening there. So we get the environment of it, the surrounding. So, having this now, taking the whole set, discuss this. Now we understood what is string take, so that's the first thing here. We understood this term. We understood this. And this says here, this is this add, this is a pure function, and this is a mapping. We knew this is a list of 2 positions, of 2 ranges in the string. So we take the first, and this means take the first element, put it here, and run this function, and run this function. And then take the next one, put it here, and then run it. So therefore we have the asterisk, we have the plus. This is called a pure function, and this is a mapping of the list produced by here. So therefore this produces a list of 2 strings around infinity in our data. Okay, So what is riffle about? That's the next thing. So riffle, let's go here. We can look it up here in the documentation or play around. Riffle says, so we have two elements. For example, hello world, and then we say no, or make it simpler. 1, 2, 3, 4, and we riffle with this. Let's look what happened. And here we see. So it's mixing up two lists. Let's look what's here, what's going on here. Just play a little around. Now you see it's mixing two lists. Yeah. So in this case, then we get the first string, we get a carriage return, and then we get the first thing. So this is a riffle here. So let's look what happens if we do it. Now you see. First, carriage return, second. So, string join. This does what you expect. If these are 3 strings, and make one of them. So let's look how it looks like. Make one of them. Okay, now we are here. So to make it proper, now this is not, especially here in the cloud, you can't only copy the whole thing, but what we always have here, these things here, they are all lists. So, for example, and you can go here with E, and then this is a cell. So you have this number here, so there's a cell, box data, this is a string, standard form, output, label, and so on. These are all the information, what you see, rendered as a cell here. So what we now do is we take this thing here and put it as a cell, as an input cell, you see. So this is the content, and this is the form, this input cell. So therefore, let's go here. What happens is not very. Now we put this to an input cell. No. So we put this to an input cell, then we have the string, and then as input. And if we print that, then we get a rendering of the cell in a proper format, which is an input cell. So, and if we go here, we see it's an input form, or we can go here for the format, and then we say style name input. Yes, here. We can put it to output or to text if we want. If we put that here to text, then we get the result as text, editable. Yeah, but here now we want to have it in mono style, and text has a proportional writing, so make it input, and the input has a proportional font, a mono font. And now we are happy with the result. So if we have this, now we can go for architecture, and we get much more of it. This is what Colas is talking about, architecture. If we want to have, for example, a broader context, then make it, for example, D, and D, set D equals 36. So D is assigned to 36, then the whole thing gets broader. Come on, here we are. Architecture. And you see it's working on capital letter, and yeah. Therefore, you see here we look for the position at 2, and take it from 1. So therefore we are abstracting here. So if this is too long, then for example you can say, this is very interesting as well, if you just want to have 3 elements, then we have a string take here, string position, so this is here, and then we can say, go for, if you want to have something, you can, for example, say random choice, and then here, and then say up to 3. So if it's only 2, like we had it with the infinity, or if there's none, then this would be an error. If you just want to, so if there's none, it would be an error. You say up to, and then it's robust. So, and then you get, it's not working. Random choice. Looking what 2. I think it's this. What I told you is nonsense. That's the only thing I made wrong. Good. And then you get random new ones if you So you also can do a button, and then you say show so have it here, but this is the, you see it with green, there's a button, so then you can go here show, and then it's always producing new elements. Yeah, these kind of things. You can make a panel and these things, look it up if you're interested, so you can ask a certain question, it's coming. Or let me look it up. It had some problems with the cloud, so I recalibrated it. It's a dictionary of the words used in a book. Let's go here, create a new chapter within your notebook, your working book. Dictionary of the words used. So what do we have? Now this is blue, which means we you can ask for it. You can ask head, what is it? Head means what is it? Data 2. And now it says it's a symbol, which means there's no assignment to this name, which means we have to look it up. So it was defined here, data, but it's blue as well with data 1, and this is with data, and data is here. So we created it, we import the data here. So we need to find our data. Now it's black. We have to go for data 1, data 2, and you can do it with your, if you have it in your notebook, you can do the same here. So it would be the same. Close it again, close this again. So now let's look what we have. This is the way how to get the words of a text. Now data is, you see, it's a string. We can ask for a string length of data2, and this is 100,000. So now everything is okay, properly set up now. There's text words, which simply says we make a list of strings, and each element of this list, so each string then represents a word. So it cuts it with commas or with blanks or with points, semicolons, and so on. We can do that. And now we have 16,000 words. We can ask, like any list, so now we can ask add of words. This has to be capital, like all functions have to be capital, and all other symbols have to be lowercase. So go for that. It's a list, and all lists can be accessed by like this, words of 100. So this is the 100th element. This is not correct. So here 100. Now it's published, and then we can say we want to have, for example, you will know it from this intro 105. So we get 2 words, or we can say to 105. So then we say 2 times semicolon, and from 100 to 105. So here we see elements of the list. So this is with the words. We don't need this anymore. So now go for the next step. That's simple to understand. This concept of stop words is, so there are a lot of words like of, and, or, and so on. Then these are stop words, and to make a dictionary, they are not specific to the corpus of a book. So that's a list of words, and we delete all these stop words. You can look it up to get the list. You even can edit this list. So take this, and let's have a look what happens. This is now, it's about half of them. Now words 1 is, these are the words, and these are now specific for our text. Okay. Next. There is this huge functionality about correlating texts with Mathematica. For example, you can ask word data on tree. What are the definitions? So then you see there's a lot of stuff here. So we can also ask, let's go here, a lot of properties. So there are 160,000 words, so we can ask for them here. Again, what is this? And then there are the properties, so the base noun, border terms, the definitions is what we had. Then, for example, parts of speech is what we are interested in, and then it asks, it's an adverb. So you can look it up. If you are on desktop, you have the full functionality in proper speed. On cloud, this is we run into problems. Therefore, I prepared a compiled version of that, and you can load this compilation with this cloud object, Meteora word data. So it's an import of this cloud object as text. We uncompress it as discussed before, and this is, it has to be named $Meteora word data. So if we load this, it's there. So you see this is not complicated. We can look at it, and it's working like this. Meteora word data. It has these 160,000 words, and we can ask for it. The word starts with an E, an Y, or then an E again. And if we can ask for content, so and then we have all the words starting with E, Y, E, and that's it. And just for now, we have the parts of speech and so-called stem, word stem. So we will discuss that later. So for word stem it's always to go, or to he goes, or going, and so on. It always has the same stem, go. So you abstract from plural or from cases and so on. So this is good to not to have doubles in the things. So it works like this. This is the a short data set, and you can access it like that. We look what we're doing now with this. This is what we want to do. We want to get the nouns for our dictionary. So take this. There is this function called Meteora word noun. We have to put it here. It's not correct. So it was blue. Changed it. So what does Meteora environment deliver? So you can ask Meteora word data, and for example ask for nouns, or world data. For example, look for this. And then we can ask for I, and then gives you the access to this data. So it's a noun or a verb, and the word stem is I. So eyeball, you get another word stem. So, or you can ask Meteora word noun Q, is it so? And then we ask, is a tree a noun? And then it says yes. Is where a noun? It's false. Good. Well, because where is a conjunction or a pronoun. So this is what we're doing. We select out of the list of the 8,000 words of the book of Kohlhaas. We select all the nouns and assign that to the symbol nouns, and then we ask for the length of the nouns. This is quite fast, so we have 4,100 nouns. So that's good. Now there are the next level, word stem. We don't want to have plural or for example, if we go here for word data, going or walking, then we want to have all the he walks, walking, to walk. We want to put that all to the same stem and count them as one. Therefore we ask for all the nouns we have for their word stem. So go here and we have them, and we can ask for stems of 12. It's a store to 14 or to 142. These are the first word stems of this book. So this is what we want to build the library, the dictionary of. Good, we have that. Now next step. And the dictionary is this. We take these stems, We delete the duplicates because there might be doubles, and we sort them by alphabet, and that's our dictionary. And then we ask for the dictionary, 1700, and then we can ask for a dictionary of 1 to 100, and these are the first words of the Kohlhaas book, the first 100 of the Kohlhaas dictionary. So that's this chapter. So, and of course, each book has different dictionaries, and then you can compare. Next step would be get the frequencies of the words used. So we use now this dictionary and look how often a certain word is used in this book. This is quite simple to do. It's done with this. Now let's go for put this here, and we need another chapter to be in sync. So we can copy this and keep the link, so we can go to and we can, with this link, we go to the source. Now, what is this? We again go to, there's a frequency. We don't need these frequencies here. Let's from an old version. So we can go, so in here we say it's counts, and check how it works, how to learn to read it. Counts, we can go for the documentation here, but let's have a look how it works. It says, it simply gets, this is an association, you can look it up, and then he says design is used 26 times, guide is 28, shop 26, 16, and so on. So normal makes that a list, and then it looks like this. So rainbow. So then we want to sort that, not by alphabet, so we can sort it, sort by the alphabet, by the first, then it's by alphabet, or we can do the same thing with take the whole list and sort it by the first part of it. So that is the same. Or we can say we go for the second part. Then we are, sorry, we have to make it a pure function. Again, first, it's too fast. Now it's sorted, and with the first, and now with the second part of each element, it's sorted. Now this list needs to be reversed. Reverse of this list, and then these are the most prominent words of the dictionary in this book. So this is very characteristic for this book, and you can compare books by that. So very popular is a word cloud, and this is given by Mathematica as well. You can look it up, different formats, nice renderings and so on. We take these frequencies, and for example, to do the 32 elements, the first 32 elements, so we can delete this as well, because we have it here. Is it here? Yes. So now these are our first 20, and take the first 20 to make it precise. 20. Make a list of it. So this is a thing. this simply takes each element and transfers it to a list. This is very interesting as well. So this is a list of rules. So if you make, for example, 4 goes to 5. So this is a rule. It's the same like rule. This is a certain rendering of that rule for 5. And then you have this. So this is a full form, and this is the middle form. I forgot the name for it. It's another kind of notation. So it's rule. So and if you say list of rule of 4, 5, then you change the head of it. So then you make a list of it. So that's how it works. So for example, you can say plus, and then it's say add 4, 5. That's the same like add 4, 5. No, a plus. Yeah. Plus 4, 5. And this is the same like 4, 5. It's 9 plus it's the same. So if you say list of this, hopefully that is wrong thing, then it first evaluates it. So this is too complicated. It's first evaluating that and then putting it to a list. So so what we do with the third one is if you have multiple rules. So here that's the same. So if you go here for a list of this, I have to put it here. Come on. So then we have a list of this. If you have multiple of this, then for example 3 follows goes to 4, then it is already a list. So you change the header of a list. So for example, you can say it's an association. Then it goes for an association. Or if you want to have a list and do it for each element of that, then you are here. So therefore, these frequencies via rules like as 61, and that's a list of rules. If we go now for this list of rules and want to have them as a list, because word cloud needs a list, not an association, here we get architecture, like, space, and so on. If we go here for 48, we have more of it. So this is about the frequencies of words in a book. So if you do it for a chunk of books, you easily see what they are talking about. Even if they are very interesting if they are with architecture. So then you see which color of architecture this book is about. So again, it's about getting an idea of the book without reading it. So, and with that we are with the next chapter, I think. No, now with the conceptions, this is very interesting as well. So take this chapter here and make it a new chapter here. So what is here? This is what it's a kind of it's a bypass story, which is very interesting. I think it's important. So this is what I give you. This is the n-gram of YouTube, not of Google n-gram. viewer. Google has a huge amount, he's scanned towards all books just to be able to translate, to learn how to translate and get an idea of what is written. And then they have these word frequencies on these books over years. So therefore now you can ask for crime or architecture, and ask for from 1800 to 19 until today in English case insensitive smoothing, and ask these books, and then you see the prominency of architecture. So you can go for crime, mobile, and so on. So we have it here. I asked, you can compare different things. I just get it from Google, just to make it more convenient and available in Mathematica. So German language, Verbrechen, Kriminalität, German 1800 to 2020, whatever you like, in a normalized view. And here you see, these are interesting things, that the conception of Verbrechen goes down, whereas criminality is going up. So do the same as here with crime. And then you see in different languages it's not the same. So and then the importance of certain conceptions are moving, and they giving over. So conceptions do have a life. They are kind towards immortal, and they have different friends. If they are in sync, they are in friendship. If they are not in sync, they are opposing and they're discussing, and they're taking over prominency and so on. So you can say absolute. Then you see that it's very you just talk about crime and nearly never about criminality in comparison. So criminality is a very special word. Crime is popular. So now this is about the n-gram concepts, and then we can compare languages. So this is about the concept, normal, absolute, in a single language, and now we can compare a single word in different languages. Go, for example, take this and paste it, and this translates crime to the different languages you chose, and then combines them. So, and here you see that in English, it's in 19th century crime was quite different towards continental Europe. It was much more prominent. So now you can go for Missetat, Verbrechen, Kriminalität, for example. Und Verbrechen. And in German. To see how this developed over time. And then you see that the Kriminalität is rising. Missetat is it's quite marginal. If you go for normal, then they are always put to 1 in scale. So then you see a certain movement, how this is turned over time as a conception. So you can apply that to the words, frequencies of words prominent in a book, and compare that within different books. And then you can go between languages, within a language, and you see how things turn. Without knowing, in this case, knowing anything about the conceptions as well. You simply count the words and compare them and look whether they are in sync or just with another face or completely independent. So whether they're a friend, whether they are flirting, or whether they are confronting, and so on. So this is the word frequencies over time, to get an idea of what the words might mean without knowing a language at all. You can do it with Polish and this will work. Yeah, I don't know Polish, but this is the same thing with Polish. Huh? Okay, not working with Polish, not there. Okay, Chinese. I don't know. Yes. Interesting. How this works. Okay, that's this chapter. Next one. Now go for the next chapter. It's copy the header and go here. Now this is about the n-grams. So it's a kind of communities of finding friends and communities of concepts within a book or within a set of books. So the key is, and this is what is called an n-gram, is with this partition. Partition is doing this. Just say partition of, you can look it up, what is here. Yeah, it's a lot of things. I give you a short introduction. So we have a list. So say 1, 2, 3, 4, 5, and then you partition it in chunks of 3. So then you have 1, 2, 3, and I get 6. And then you have 2 chunks of 3. So the next variable is what we are doing here is that we just have an overlap. We move always once. So therefore we have an overlap of 2 to create these triples. So what we do now with our stamps, which is not a sorted dictionary, but it's these are the key nouns. These are the important nouns of the books in their sequence. Now we look how they have their 5 neighbors. So it's an n-gram and 5 gram. So so we look. Here you see school is moving. Everything is moving, and we say these are always friends. So this friendship got points. So this is done with this function. It's we get word friends. So if we evaluate that, it's like this: get word friends. It's complicate or takes too much time to explain it. I think it's not this important. It's a little too complicated for you as a beginner. Get friends of rational. In this book, we need the neighbors. So the neighbors is in 5 gram, the rational, and then we see get word friends. A word list, so it needs a list here. Needs a list. So then we say rational is friend with share, program, modern, and fallout. Then program is friend with variable, follow, share, science, ratio, and purpose. And we say up to 6 is here. If we want to have 12, change it here. So this is this function. And now we can use this one here. And this says, for the word rational, give all the friends, then give the friends of the friends, and give the friends of the friends. Do it 3 times. Then we could say this set is a word community. So let's check how it works. So then you see, ratio is friend with share, ration is with program, program is with follow, modern with stage, and so on. You can analyze it, but it takes time and it doesn't. I think it's not worth it to go. Just run it like this. And this directly can be displayed as a graph of friendships. Or this is a map of the community around the concept of the ratio. Ratio, and you see how these connections are. And they are always very characteristic for a book. For example, you can ask for architecture. Then you get another set and show it, and then you see architecture, modern, 20th century, big space, and you're directly with Koolhaas and his junk, think, time, public, and you see how it works. So we can check for 4, then no, it's okay. I think this house, then we have another one. Yeah. So this is the next chapter. Now find sentences containing a word. So now if we have this analysis about words, about the friendships, communities of words specific for a book and an author, then we want to find the proper paragraphs and sentences containing these words, so then we can go to detail and get citations and read in detail. So, and this is done like here. Again, copy this header for your notebook. And now, first we get the data. Data is in the first chapter here, import in a book. Okay, so first we want to have, close this, the paragraphs. So we split the data with the carriage return, and this is then these blocks, and then we name this. So let's look what it has. So we have 129 blocks or paragraphs, and the paragraphs, for example, number 12 is like this. So it has a name, so we give it a name Koolhaas, and that's block number 12, and this is the paragraph. We'll go for 13, and then we have the paragraph. So because it's a scan of a book, then we have a page break, and this is not the end of a sentence. This is not good, or it's too long. So we go for some correction of the paragraphs. Let's go here. This is here, paragraph 1, broken join paragraph. So this is the page broken paragraphs, and then we assign that to paragraphs 1. So here, and then we only have 52. So for now, this is okay. We will use it later with. Let's remove this. In the next paragraph, the next chapter, we will continue with the paragraphs. Now we are interested in the sentences. Now we have full sentences of our scanned book, and now we say for each of these paragraph we want to have select the sentences, text sentences for each of these and we only take sentences larger than 60 characters. So you can analyze this as well. Now we have 534 sentences of 45, and here we are. So this is a proper sentence, and here we are. So take it as it is. It's working properly, and we can talk about it if you get problems with that. So now, string to find. If we want to go for string to find is, for example, if we want to go for water, then we ask string to find to lowercase case, so we don't want to make too much, we want to abstract from this. For example, we can ask here, this is the key, the center, the core of this function again. So let's check it. String contains. This always takes a string and a pattern. So we can say, for example, here, water, melon, and string to find. Let's say water, and then system says yes, water is there. I put it. This is false, and because we make everything to lowercase, this matches as well, or this matches. So that's it, what we're doing here. This is a pure function, and this is applied to all the sentences we have, the 500 sentences we have, and we select the ones which contain water, independent of whether it's lower or so on. This is called our selection. We apply that to our selection. What we do here is, we can check it here. We look which position it's, so we select it, and then we look at which positions in this list of sentences this selection is. So let's look for here. And then we see it's in sentence 192, 21, and so on. So this is a list of sentences containing water in our book. So to get these actual sentences then it's very simple. Then we have the sentences of. This is assigned to selection, and then we get the sentences. Come on. Here we are. That's a lot. Yeah. So these are the sentences, the long ones. So what we now want to do is put that in a proper format, and this is done with this. Make it nicer. This is done here. We had it already. There's a function called text highlight paragraph, sentence off. So we have and then string to find. Put that to text data and do it with all the selection and say print, which gives us the sentences to print with highlighted water. So this is to get the content. Here we go for architecture, operational, or junk space. Junk space is verbs. Oh yeah, yay, that's a lot. So then this is too much. So go for random choice of this and give 6 samples. Here we are with junk space. Other ones. Yeah. Political. And there we are with political sentences. Good. I think you are able to run that with your books. And now the last paragraph. It's a semantical search. This is the most interesting in principle. So now we are first time using AI. So we have to go more detail in the paragraphs. Now we paragraphs. Now you've seen in this book. In this case, we had 54 paragraphs. So and this is too large. So we want to work not on small sentences, but on a few sentences. So some 300, 500 characters, and so then if a paragraph is too large, we split it in multiple. So and this is a function for that. So we have, instead of 50, we have around 200 paragraphs we want to work with. So here we only get the paragraphs which are larger than 100 characters. These are 189. So it's very often that you have, for example, the title always, or then the footer, and this works as a paragraph, but if there's no content, so and we just tested with the amount of characters of a paragraph. So now we have 189 reasonable paragraphs. So what we do now is in AI, for a semantical search, we take all these words within a paragraph and these are the word vectors. First put the lowercase word vectors and make a vector in a multidimensional space for a paragraph which is which makes a certain character most distinct to all the others of a set. And our set are these paragraphs of our book. So let's look what happens. It's a feature extractor. So now we have a function. So this function is called fe, and this, if we say hello world, we get a number, so a vector, you see that, for each word. This is for hello, the first word, and this is world. So, and this is characteristics for the book. So, let's go further. Now dimensionality reduction. What we now do, we go with all the paragraphs with the book and apply this function to all the paragraphs, normalize that, normal that, because it's needs a list, and reduce it to the paragraph then, not all the words within the paragraph, but the paragraphs to a vector of 60. And this is a function again. So now if we go with fe, so dr of fe of hello world, we get a 6-dimensional vector characteristic for this text. Now go and apply all these functions to the paragraphs. Take all the paragraphs, do the feature extraction, do the dimensionality reduction, and now keep the mapping and the links, and these are our paragraph vectors. So we have all the vectors, and there you see it's super fast, and that's enough. So now we can ask here, this is a book, ask my book for a text. So what we can do is paragraph of, you see here, this is a key of this function. So we take a text, for example, hello world. Txt is hello world. So then we get this vector for our hello world. PV, you can look what it is. First step is head. It's a list. Now we can ask for the dimensions. Of this. 189. So now we can look for PV of 4. This is again, okay, this is so we have this vector for sentence 4. Okay, therefore we didn't get the dimensions. Dimensions of PV all 2. The first it's always a vector here. We see it's 60-dimensional. We have a 6-dimensional vector for each paragraph, and there are 189. So nearest is another function which works like this. We can say 2, 3, 4. So, and we ask what is the nearest with 3.2, and then he says it's 3. 3.6. It's 4. If we kill the 4 and put in 12, this is a mistake. So then it's 3. If we go for 7, You get how it works, yeah? So if then we say nearest of our paragraphs to the text, and we want to have 3 elements of that, or we can have, for example, the nearest 2, it's 5 and 6. So we want to have the 3, and then these are the paragraphs of it. So the nearest, these are paragraphs 76, 68 and 29. And now look at this. And these are the 3 paragraphs. So it's Kohlhaas 62, Kohlhaas 15, and the other Kohlhaas 54. They are nearest in these feature extracted, dimensionally reductive texts. So this is then again cell, text, cell print. So this is Ask My Book. Go for Ask My Book. Ask My Book of Hello we have it here, Kohlhaas 10, and so now to test whether it's working, for example, take this as a text and ask the book what it thinks about this text, and then you get the proper thing and corresponding texts with a similar location in feature space. So now you can take any kind of book. Tell me something about junk space and architecture. Then this is the answer of Kohlhaas' book. So I think this is what you need. And what you're expecting is that you somehow get this working, that you with 2 different books of your interest, and then you have to start to analyze and discuss these books along these lines of analysis, and discuss these books and write an essay about these books talking with each other, compared. Thanks for watching. Hope you can manage it, and see you in our open hour for questioning.